Hello, and welcome back to the third in the series of webinars where I'm going to be pulling apart Industry 4.0, but mainly with a view to manufacturing. The aim of these series of webinars and eventually workshops is to join the dots. I think I've said this several times, but there's far too much confusion out there and the marketing is out of control and not helping. Nothing's being defined that well, and it's leading to lots of confusion. So today I'm going to be joining some really very important dots together. So buckle up. We're going to be talking about the importance of physical assets and structure and how that connects to data structure, which, as I said before, is one of the cornerstones. There is, for those of you who know, there's a common name for some of the data structure coined by Walker Reynolds, which is the UNS, Unified Namespace, which is great. It's using the word unified. We like unified because it means joined up. And this is, to be honest, a lot about what I'm talking about in this series is trying to join things up and make sure it's a unified approach. So not just the data, but in the management philosophy and also the modularity, if you like, and the importance of standards. Okay, so standards are important, but I think they're always lagging behind. That's the first thing. The second thing is they are guidelines. The reason is that they're set out with all the best intentions, but I think exactly what I'm going to be talking about today, which is S95, S88, and some of the work that OMAC have done and why they've done it. Because whatever we talk about in manufacturing, this is what I said before about connectivity, architecture, and data structure has got to be good for the whole manufacturing environment, the whole factory. Because we need to involve everyone. So the other important part is the fact that it's human readable. All right. So this is why the UNS is so popular, because people can actually understand it. It's a unified namespace. Namespaces are used, but they're not super friendly. Okay, they're really aimed at more of the software orientated people, but they're not the people that are going to be wanting the data. So you'll see down here in the bottom corner that I've highlighted here the human readable UNS. So let's talk about the importance of a joined up approach. So here you'll see a picture, I took it, is from a new building site down the road from me, and I'm gobsmacked, you know. So there we go. So the plan was to put the lamppost in front of the Juliet balconies in front of the flats. Genius. So obviously it's going to cost money now to move it, or they leave it, and you know, who's going to want a Juliet balcony with a lamppost right outside? Sorry, I diverge. But anyway, the important thing really I'm going to be focusing on is here. And so a lot of people talk about S95, of course, that's good. And some people talk about SE88, and what has been done and what maybe not so many people know. So there's ISA TR8895. Okay, so this is where we join, in some ways, join them together. Now, people have had a lot of problem with S88 and 95. When you follow it religiously, they're very hard to marry up. My argument is I don't care. The reason I don't care is because what I want to focus on is the physical assets and how they connect and interact. I don't really need anybody to tell me how my ERP MES system is going to communicate and how all the functions work together, because to be honest, all of this needs unifying. And the reason it needs unifying is because some people have more experience with process. Some people have more experience with packaging. Some people have more experience with warehousing, and so on and so forth. So I'm not entirely sure that anybody has a complete picture. Now, I have a wider picture. I'm not saying I'm all knowing. However, I don't really care too much about standards. They're there for me to use, and they're there to make sure that people don't have to reinvent the wheel. Okay, so if I look here, you can see the S88 physical hierarchy, which actually goes into more detail. Originally developed to help build modular batch process, basically to help in the design of batch systems. Batch manufacturing is big in the food industry initially. So, and then we've got to worry about the packaging line as well. And the packaging line probably, and this is why OMAC did what they did, and we ended up with TR 8895, is because the packaging world tends to get in a engineering point of view pretty complex. Okay, I'm not saying there isn't complexity in process. It's just the amount of components in the packaging system, especially these days, is much, much more complicated. Now, it is touching process. Just quickly, I'm going to just touch on this quickly because I want to show you that process is not alone. So if I come up here, sorry, the controls are a bit delayed. So what I'm also going to be talking about really is layers, transactional layers. I will come down to that in a minute. I'm going to stick with what I'm talking about for the minute. So this is MTP. This is fairly new, I would say. But what it does is it brings modularity to the process world. Okay, so this has been adopted to some extent by healthcare and pharma just because of the sheer costs of adapting the plant to meet new manufacturing needs. So you can see here the principle of it. You have overall orchestration, then you have the process modules, which can be reconfigured in any way, and then the orchestrator knows which order they're in, and then the recipe handles the rest. So I could talk about this a lot, but for today, let's just conclude very quickly that modularity applies to process as well. Okay, so let's go back now. Sorry about the lag. I think my computer's struggling. Right, so layers. This is the traditional layered approach for the automation hierarchy. Actually, there's components of the S95 standard that actually say you don't want too many transactional layers. It leads to cost, complexity, and doesn't behave very well. Doesn't handle redundancy so well, or doesn't handle errors so well. Totally agree. So I tend to not think about that, and what I'm going to talk about in 5 or 10 minutes time will actually expand on that slightly. But also, when you look at the vision of adaptive manufacturing and certain extent 4.0, they're talking about intelligence on the floor, right? So why would you have this pyramid? So to be honest, it's time to kind of remove the pyramid from our minds. I know why it was done, but I think its day is well and truly past. So let's talk about the packaging side for a minute. This is where adaptive manufacturing, I'm talking about primary and secondary packaging. I'm not going to distinguish between the two. So S95, you can't really use, you could use it on its own, people do. However, it's not granular enough. Okay, so on the S95 side, you can add another unit below a unit, but let's try and be structured about it. So if I go up here, S88 goes down to more of a modular layer and even a control module. What that means is it's not a controller. What it means is it's a valve, a pump, or whatever. It's something that's being discretely controlled. And when you look at the OMAC, it expands on that basically. And so what I've done here really is we've got the cell or the line, the unit or the machine, the station or the module, and then the actuator / sensor. But there's something else. So this is really getting down to the importance of the physical assets, okay? But what we can't forget is the software. And this is where adaptive manufacturing and reusability really comes in, okay? So if we have the control code, and software engineers have been doing this for years, we want to reuse these modules of code. So why not have a module which actually represents a physical asset, and then that is inserted into essentially another function block which represents the, say, next level up, the asset next level up, and so on and so forth. So eventually you can end up with almost like a function block for your factory. And this is absolutely possible. The only thing that I would say you need to think about, and this is something that I'll be touching on again in a minute, is, the time series. And this is where things start to get interesting. So there we go. So time series data. So the time series data down at the actuator level can be around the millisecond, and it can even be sub-millisecond. In fact, lots of the newer control systems that I've worked with over the years are well below the millisecond, and if you're doing condition monitoring, you're normally below the millisecond level, but that doesn't need to be passed up. Bear that in mind. But it's something to think about when you're doing the structure. So not only have you got more modularity, but you also need to think of things in terms of time series as well. So just a quick introduction to OMAC. So OMAC have done a lot of great work. Some of you may know PACML, things like that. So if you're doing PACML and you stick to it religiously, then you end up calling things stations, and then you have a definition of machine and stations within that, and then the components or actuators underneath. And so if you don't know much about them, go and have a look at the website. There's some good information there. It really is about people on the ground getting together to come up with a series of best practices. So here, right in front of us, just before I move on, I could go on, but I'm not. I'm not going to. Got to be careful of the depth that I go into. So adaptive manufacturing, as I've said, more granularity, and so you can't separate this. All right. So the human readable UNS is hugely important, and the reason it's hugely important is because you're talking about a factory, manufacturing plant, and you're talking about everybody is going to be contributing. So it doesn't matter if it's going to be the quality department or it's going to be the R&D department. They're going to be able to navigate and access data. Of course there's permissions, there's security, of course there is, but these people are going to have to be able to do it on their own. You can't have one entity determining exactly what people need to be able to see. You don't know what they're going to need to be able to see. There's going to be incredible amounts of data available, some of it very, very specialist. And so, what might be interested to someone in the engineering department about condition monitoring might not be interesting at all to someone from the quality department. And this is really the definition of, a unified approach. You got to think about everybody, you got to think about all the assets, and you got to think about what might be needed in the future. And this is why vision doesn't meet the strategy and it doesn't meet the needs of the shop floor, basically. So what I'm going to do now is to zoom out a little bit. Obviously, to summarize quickly, we've talked here about a more joined up approach, a more unified approach to data, about assets and the connectivity. So the connectivity architecture is important. This is where I'm going to be diving into this second half almost, or the second third probably of this webinar, is going back to what we talked about here regarding thinking about chiplets as, you know, a sort of representation of your manufacturing plant, your factory, basically. So just to recap on what that actually means. So very quickly, a few years back, AMD, for example, decided that they weren't going to have that monolithic substrate, monolithic die for their processes, their compute units, as it's known these days. So what that actually means, if you come into a little bit of detail, and the advantages I'll touch on, because obviously that's really why we're doing it. So here you can see a rough example of what this actually means. So you can have the different functions within the chiplet specialized and made more cost effective. So you can see here the flash might use bog standard 40 nanometer, and then, you know, some of the higher level processes will be needing the lower, you know, or now we're talking about 4, 6 nanometers and maybe even down to 2 or 3. And there's huge cost benefits for doing this, right? So this is what I was talking about. If you think of these as the cells, the areas, the cells, lines, machines, etc. in your factory, it can open up huge opportunities, basically. So just to summarize quickly on what this actually means, here we go. Here is a diagram I picked up of 3D Insights, and it can show what the monolithic system used to look like. And you can see here that with the chiplet approach, we have huge benefits for doing this, for decoupling each of these modules, but we do have to take care of the interconnects. So this is what I'm going to be talking about now. So, and the consideration, which is what I said earlier in the webinar, that we do have to consider, and this is the same for chiplets, is the time series. Okay, so if I come up here, you can see that we do have to consider the time series of these layers, if you like. Not layers, but the time series of the modules that we're actually talking about. So down to the why, this is super important. So this is really why we're doing this. This is why we're decoupling and modularizing our manufacturing assets. This is really why we're decoupling and making our assets more modular. So you can see here how it's broken down. So the design is more complex, but the benefits really is down here. The scalability, the cost effectiveness, the cost efficiency of not having this monolithic design. You know, it's more resilient to defects and things like that. So faster time to market, optimizing your performance, that's critical to manufacturing, and then flexibility and scalability. So these are all common languages that or common words that we like to be hearing, okay? Now it does go into a bit more detail. I have copied this. This is some of the standards for the interconnects, but it's not so relevant. What I do want to, right now anyway, what I do want to touch on is this. And this is really, this is the core. This is the core of what I'm talking about. This is how I thought best to convey it, because it is quite a complex process to explain it. I can't imagine how many words it would need to explain this. So this is what I'm trying to convey. So the area, cell line, the unit machine, the module, the station, and then the control device module. And this is what I'm calling, this is the unified result. So this is the model that is applicable to process as it is to the packaging department, and is applicable to services, it's applicable to the warehouse. Now, one thing, a very important thing that gets missed, is the control elements, and also this is purely from a controls point of view, I would guess. So this is something that can't be ignored. So down here we have the physical layer, right? So this is really the bedrock of how we want to be thinking, everything based on our physical assets. And then superimposed at the very top here is the data hierarchy, which basically marries, you can see here, actually lines up perfectly with the physical assets. Now, in between this is the control elements, and this is an important part when you're decoupling and you're making components modular, is you've got to bear in mind what control functions, what automation functions you want in each of these modules. Now, this is what I was saying before, is you need to think in terms of what data do I need to transmit in real time and what data can be transmitted in non-real time. So, traditional Ethernet or whatever. This can't be ignored. It's all totally possible, but this is why I think some people have been nervous in the past about going fully modular. Now, you can absolutely do this. I'm not going to go into too much detail today. There's lots of important points here I'm trying to convey without, blocking everybody's mind with some of the details. So what I do like to do is to show where there's a control element. It could be a fixed asset, it could be a movable asset. And I do like to show where possible the type and function of data. Now, it doesn't mean, when I say type, it doesn't mean a specific type of data. What it means is type and function together. So it could be OEE data, it could be MES data, it could be data from the factory up, it could be condition monitoring data, it could be data about the status of the production run or whatever. But the point is, the map can't ignore this. So yes, you think about the UNS, of course, but within that superimposed image, which you can see there, we do need to think about the different types of data that are applicable to that module, that asset. And this can go all the way up to the factory, down to the area line cell. It can go all the way down. So within these components, if you like, these chiplets or modules, you have all this different type of data. I will expand much more on the data side. Walker Reynolds and 4.0 Solutions have done a lot of work. I'm going to talk a little bit more detail about the implications when you go into this more, or the more granular approach underneath. But today I'm just going to stick to talking about this, because this is the core of really what we want to do. So if I zoom out a little bit, again, what we're never losing sight of the time series, okay? So the higher speed time series data doesn't always need to find its way to the top. So this is really what we can sort of visualize. Now, I have expanded this. Some of you may have seen it in the mind map when I've zoomed right out. But this is essentially the beginner's sort of guide to decoupling and how we make or map out the components, the modular components of our plant in line with a unified S88 S95 OMAC model, okay? So you can see here, I've shown the services, I've shown the goods in. So this is where we start to get more and more granular. I haven't done it for the whole map for good reason. It would have been probably too confusing, but what you can see is where I've nicely in pink, is where I've decoupled the process cells transportation from each other. Now the decoupling makes you much more resilient and adaptive. Okay, there's good reason for doing this, and somewhere in there is always some form of transportation. It could be AGVs, AMRs, it could be a fixed transportation system. There's lots of different options with lots of different advantages, etc. But you can see really is how I've divided it up in line with the data map in terms of the physical assets. Then what we need to do is to determine how the modules with a lower level time series, a control aspect, talk to each other in real time. Now, do they need to transfer information or not? This is really where we come back down here. So I'm not sure how quickly this will, or how well I've explained all this, but this is the fundamental thing we need to resolve, is to create a unified map of the factory, which is both applicable to physical assets, it's applicable to the data, and we show what tools we need where from a control operator's point of view, and we need to take care of the synchronous data transmitted between them and the non-synchronous. Okay, so hopefully this has given you some insight in how we can unify lots of these different topics and bring them together, which will save enormous amounts of time basically. And I think the other important thing is this skills spectrum, which is what I came back to. Any of these company initiatives for digital transformation, Industry 4.0, and more specifically adaptive manufacturing, will need lots of different input from lots of different people. And so it's of utmost importance that everybody can really see in their mind's eye how the factory is being mapped out. And of course, once you've done this, there's no reason why this can't be part of the factory visualization. And we don't even have to stop at the factory. Okay, this type of philosophy on the publish and subscribe model for data, which is what I'm going to be touching on a bit later in other webinars, is how that scales up to the corporate level and also to the supply chain in general. So hopefully you found that interesting. I'm sure some of you out there will have lots of questions, which is absolutely fine. You can post them down below, or we can pick them up in the live events later on. So that's it for today. Thanks again, and look forward to talking to you soon.